Welcome to All This Math. This is Professor Parker, and today I'm doing a video for my nephew Amir down in Baltimore. We're going to talk about some math word problems. All right? So, let's read the problem first, because whenever we see a word problem, we want to read it, because we have to know how to read and comprehend what we read before we can actually do math. All right? And reading and mathematics go hand in hand, so always remember that. So, it says that Hanifa drove 550 miles in 6 days. So over a 6-day period, maybe we're talking about Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's 6 days, I think, right? But in that time, altogether, she drove 550 miles. That's a lot of driving. Then it says that she drove the same distance each day. That's very important information. We'll talk about that momentarily. Then the question, how far did she drive each day? All right, so that's what we're trying to figure out. You always want to read the word problem and do your best to understand the word problem. And then we have to also know what we're actually being asked to do. Like, what is it even asking you to do? All right, it's asking you to find out how far did she drive each day. You don't know how far she drove each day. You know how far she drove overall, right? Altogether, she drove 550 miles, right? But you don't know how much she drove on each of those 6 days. So each of those 6 days, right? We don't know that, but we're going to figure it out. Now, one problem that a lot of people have with word problems is that they don't know what to do. Like, they know how to do some math, but they don't know what type of math to use to answer the question, right? Now, when we think about the 4 basic operations in mathematics, there's addition, subtraction, multiplication, and division, right? So what I want to show you is, like what happens when we try the different operations, because some people don't know what they should do, so they just start doing anything, right? They say, oh, well, I know how to add, so I see a 550 and I see a 6, so why don't I just add them together? And some people would do that, and they would do this, and they would write this on their paper. They would do 550 plus 6, and they would get 556. And they don't know why they're doing that. They don't know why they're adding, right? They just know that, well, adding is part of math, and this is a math problem, so I'm going to just try to add, and I'm going to see what happens. And they get 556, and they say, okay, well, that's the answer. She drove 556 miles each day. But you got to stop and think to yourself. When you're doing math problems, your answers should be reasonable. Your answers should make sense. Would it make sense that she drove 556 miles each of these days if altogether she only drove 550 miles? That wouldn't make sense at all. And since that wouldn't make sense at all, that tells us that we should not be adding, because adding will not give us the answer that we need in this type of problem. All right? Now, there are 4 basic operations. We just figured out that adding has been eliminated, right? We're using something called the process of elimination. Process of elimination. So we know adding is not going to help us. Some people might say, okay, well, if adding don't work, watch this. I'm going to subtract because I know how to subtract. Watch this. So they'll subtract, and they'll do 550 minus 6. And they might, do 550 right here, put the minus sign, put the 6 right here. They might say, oh, 0 minus 6. Oh, I know I got to borrow from the 5, turn that into a 4. That's going to make this a 10. And then 10 minus 6 is 4. And then 4 minus 0 or nothing is also 4. And 5 minus nothing is 5. And they say, look, I got the answer. She drove 544 miles each day. And then you say, wait, hold up. How can she have driven 544 miles each single day if she drove 550 miles altogether? That would mean that after the first day, she drove 544 miles. And then the next day, she drove another 544 miles. Now, we don't even got to keep going on, because we already know that that's way more than just 550 miles, right? Because if you drive 544 miles and then another 544 miles, you're already over 1,000 miles in driving. But the problem says she only drove 550 miles. She only drove 550 miles, right? So again, this is another operation that we can eliminate. Subtraction is not going to help us. All right. Then somebody might say, oh, well, let me watch this. Check this out. I'm a multiply. All right. So they say, okay, watch this. Multiply 550 times 6, set him up like that. 6 times 0 is 0. 6 times 5 is 30. Write the 0, carry the 3, right? Don't write the whole 30 right there. 6 times 5 is 30, and then add the 3 that got carried, and you got 33 right there. So that's 3,300. So they say, okay, well, each day she drove 3,300 miles. And then you got to say, wait, how does that make sense? How can she have driven 3,300 miles each day if she only drove 550 miles altogether after all 6 days? We got to think about this. So that tells us that multiplication won't help us. But what about division? Right? Now, through process of elimination, we know that we need to use division, right? Because we don't add, we don't subtract, we don't multiply. And how do we know that? Because our answers were unreasonable. When we got those answers, they were unreasonable. It was unreasonable that she could have driven, Hanifa could have driven 556 miles each of these 6 days. It was unreasonable that she could have driven 544 miles each of these 6 days. It was also unreasonable that she could have driven 3,300 miles each of these 6 days. It's just unreasonable, right? So division is where it's at. Now, for the future reference, so you'll know when you see a word problem that talks about, you see words like same, you see words like each day, each minute, each hour, each person. Those are buzzwords that give you a hint that you should divide. That's what those buzzwords do. They kind of let you know, right, and insinuate that you should be doing division, right? Because what we're really doing is we're saying, okay, altogether, Hanifa drove 550 miles, right? But she did that over a 6-day period. So that means she drove some day 1, then day 2, then day 3, day 4, day 5, and day 6. But what we want to know is how many miles did she drive each of those days? Now, here's another thing, a little sidebar. Why do we care? Why do we care? Well, we care because let's say Hanifa works for a government agency and she's using her own car to travel around. And as part of her job, she gets reimbursed for the mileage. So she gets reimbursed because that's wear and tear on her car, right? That's gasoline she has to buy. That's tolls she got to pay for, right? So her job is like, well, you know what? We'll pay you back, but you just have to let us know how many miles you drove each day, right? And then they might also say to her, well, if you go over a certain amount of miles, then we're not paying for all that. We'll pay for some miles, but we're not paying for, like, if she did drive 544 miles in one day, we're not paying for all that, Hanifa, right? So this is why we need to know these types of things, all right? Because also when we encounter math problems, we want to think about what's the point? Why should I care? How is this going to help me or somebody else in my community? Why do I need to know this information? That's another thing we want to also think about. So we want to take this 550 miles and we want to divide it up evenly, right? So you can think of it like this. 550, little bit, day 1. Some more, day 2. Some more, day 3. Some more, day 4. Some more, day 5. And some more on day 6. So basically what you're saying is it's kind of like you're taking this 550 miles and you're sharing it with each of these 6 days. You're sharing this 550 miles with each of these 6 days, right? And you're sharing it evenly, right? See, division, when we divide, we use division in mathematics. It's all about equality, right? We divide things up equally, all right? Because math is about equality and about balance, okay? So now let's do some division. Now, it's a few ways that we could divide. I'm going to use long division, all right? I'm going to use some long division. All right. Now, when we use long division, we use a long division symbol, which looks like that, right? And in case you're wondering, this symbol is actually called a vinculum. Vinculum. It's a vinculum. All right. Now, one number goes outside the vinculum. One number goes underneath the vinculum. Now, the number that goes underneath the vinculum is called the dividend. It's called the dividend. The dividend is the number that's being divided up, or the number that's being broken up into equal parts. In this case, the number 550 is being broken up into equal parts. So we're going to write the 550 in here like this. Boom. All right. Now, the number that's called the divisor goes outside the vinculum, right? The divisor tells us how many parts we're breaking it up into, or how large each of the parts that we're breaking it up into are, how large they are. In this case, we're breaking 550 up into 6 equal parts because we're talking about 6 days, right? And on each of those days, she drove the same. That's equal. Same means equal, right? So we drove the same amount of miles, right? So we're breaking this 550 up into 6 equal parts. So that divisor, 6, goes right here. And that's how we set up our long division problem, all right, when we're using long division. There are other methods for doing division, but this is one of the ways that I'm going over today, all right? I'll do some other videos where we talk about some of the other methods like partial quotients, box method, and some others too, all right? Now, this is how we get started. We take this 6 and we ask ourselves, we look at the first number in the dividend, which is 5. The first number in the dividend, which is 5. We ask ourselves, how many times can 6, or how many 6s, I should say this, how many 6s can fit inside 5? And I say, well, 6 is bigger than 5. So that means 6 can't fit inside 5. Not a whole 6. A fraction of 6 can fit in 5, but not an entire 6, right? And when we're doing long division, we're worried about numbers that can fit, the whole number that can fit. We want the whole number to fit inside the number. So it doesn't work for just 5. Whenever that happens, we slide over to the next number. Now we make it a 2-digit number. Now it's not 5. Now we're looking at it as 55. So now we say, okay, how many 6s can fit into 55? And now here's the part where we have to know our multiplication facts. We have to know our multiplication facts because we want to think to ourselves, well, is 55 a multiple of 6? Meaning, can I multiply 6 by a whole number to get 55? And I say, nah, I can't do that. I can't do that because 6 times, there's no whole number I can multiply 6 by that will equal 55, right? That number doesn't exist. But what multiple of 6 comes close to 55? So basically what I'm saying is this: 6 times blank equals a number close to 55, right? And as I think about the multiples of 6 that I know, the number that comes to mind is 54. Because 54 is the closest multiple to 55 that is less than 55, right? Because we don't want one that's greater than 55, right? We want one that's less than 55. So I say 6 times blank equals 54. And then I say, okay, well, I know that 6 times 9 is 54, right? So that means that I can fit 9 6s into 55 because 9 6s make 54, and 54 is less than 55, all right? So I take this 9 and I write it above the ones place digit in 55. All right. And also, here's another thing I want you to know. So make sure you put this in your notes. When you're doing long division is basically a pattern of steps. 3 steps. Divide, then multiply, then subtract. And then you repeat the process. Right? Divide, multiply, then subtract. We just divided. We basically did 55 divided by 6 to get 9. Right? Even though there's a remainder or a leftover, right? Because actually 54 divided by 6 equals 9, all right? Now we have to multiply the 6 by this 9. So what is 6 times 9? 6 times 9, we already know, is 54. So then you take the 54 and you write it right here. And then we're going to subtract. So we divide it, then we multiply, and now we're going to subtract. So 55 minus 54 is going to be 1, right? And now we repeat the process all over again. So we're going to divide, multiply, subtract. But we're not going to try to we're not going to try to see how many 6s fit into 1. We're not going to do that because this 0 needs to be brought down, right? The 0 needs to be brought down. So now we're going to say, okay, well, how many 6s fit into 10? Or really, we're dividing 10 by 6. So we say, how many 6s fit into 10? Only one 6 can fit into 10. Because if you do 6 times 2, you get 12. And that's more than 10. So only 1 6 can fit into 10. So since 1 6 can fit into 10, I put a 1 right there. I just did my division step. And then I go to my multiplication step. Divisor times this partial quotient. That's technically what it is. It's a partial part of the quotient, because the quotient is the answer that you write above the vinculum. So 6 times 1 equals 6. Anything times 1 equals that number originally. All right. So then we write the 6 down here underneath of the 10. And then last step, subtraction. So we got 10 take away 6. 10 take away 6 is 4. And that's because we know our subtraction facts, right? So 10 take away 6 is 4. Now we look up here to the dividend. I don't see any other numbers up here, right? So that means that 4 is our remainder. Now there are ways in which we could keep going and find a decimal answer. We could do that, but we're not going to do that today inside this video, all right? So what we're going to do is we're either going to say that the answer, and this is how you will write the answer. I'm going to give you 2 different ways to write the answer. You take the number on top of the vinculum, which is 91, and you say 91, and then this number that's underneath of the subtraction line, right, that we end up with, that's our remainder. That's the number, that's the amount that's left over, right? Because this is really what happens. If I was to multiply 91 times 6, 91 times 6 would give me 546, right? It would give me 546. But you would say, but I thought 91 went into, doesn't that mean that 91 goes into 556 times? It does, but there's a remainder of 4. So you'd have to add the 4 in order to get the 550 miles, right? So 91 miles, so we could say she drove 91 miles each day with a remainder of 4 miles left over, or we could get more specific, which is what we should do because this is a word problem, and we create a mixed number. So we could do this. We say 91, and we take this remainder number and make that our numerator of our fraction. And then we take the divisor and we make that the denominator of our fraction. So we have 91 and 4/6. But another thing that we should do, because we should always reduce our fractions or always simplify our fractions, this 4/6 can be reduced or simplified because 4 and 6 have a common factor, which is 2. 2. So that means I could divide each of these numbers by 2. So 4 divided by 2 gives me 2. 6 divided by 2 gives me 3. So really, Hanifa drove 91 2/3 of a mile for each of those 6 days. All right. So word problems are important, but we have to always know how to read the word problem, interpret what's going on in the word problem, and most importantly, know what we're being asked to do and what operation we have to do to get there. And we have to always make sure that our answers make sense. We have to recognize that, oh, if I add those 2 numbers together, that answer doesn't make sense. If I subtract those 2 numbers, that answer doesn't make sense. If I multiply those 2 numbers, that answer doesn't make sense. So if you haven't memorized the terminology, which dictates to you which operation you should use, just try the different operations and see if you get an answer that makes sense. Now, it makes sense that, to say that, oh, she drove 91 2/3 miles each day. Because if you say, okay, well, if she drove 550 miles altogether, if she drove, let's say you don't even think about the 2/3 part. Let's say you just drop that off. And you're just thinking about, and you don't even think about 91. Let's say you just think about 90. You say, okay, well, she drove 90 miles on Monday. Then she drove 90 miles on Tuesday. That's 180 miles. Then 90 miles on Wednesday. That's 270 miles. Then 90 more miles on Thursday. And then you notice how your numbers are getting larger and larger. And you're getting closer to 550 miles. So that tells you right there that division is the way to go. All right. So just a little word problem, interpretation, and some long division. I hope this has been helpful. Again, Amir, hope this makes sense to you. Let me know. Holla at me and let me know if this explanation made sense to you. All right. For everybody else, please like the page. Actually, like the video. Subscribe to the page if you haven't already. Share the video. Tell some other people about it. And always remember, there's all this math all around you. Peace.